Hello, and welcome to the 2021 Better Buildings Summer Webinar Series. In this series, we are profiling the best practices of Better Buildings Challenge and Alliance partners and other organizations working to improve energy efficiency in buildings. My name is Paul Torsolini, and I'll be your moderator for today. I'm a principal engineer at the National Renewable Energy Lab and work on research and application efforts to move towards zero carbon and zero energy buildings. I'm also providing technical support for the low carbon pilot. Last fall, Better Buildings rolled out the low carbon pilot. It's an effort to showcase real pathways to low carbon buildings and manufacturing plants. We have over 55 partners that have each selected 2 buildings for the pilot. Partners are striving to use less energy, achieve operational savings, improve resilience, and switch to less carbon intensive fuels, which has led to today's discussion on electrification. Every building is important on a pathway to portfolio goals around reducing energy and carbon. The effort is creating what we call action plans for these buildings to be able to show those pathways and identify the barriers. I often ask the question, why can't you achieve zero today? What is stopping you? That really becomes the foundation of the effort, how to get you kind of unstuck and how to get you to make progress towards your end goals. Often in this topic comes up electrification, and most of that electrification discussion focuses around heating. So today's webinar is really to help you think about electrifying. I want you to start thinking of questions for the panel now, right? Go back to where I started. What is stopping you from electrifying today? What is stopping you from moving to all electric buildings? I will use a simple example of a hot water heating system to help frame today's discussion. I could use natural gas to directly heat a unit of hot water. That natural gas heater has an efficiency, and there are gas system losses to get the natural gas to my building. And so I need about 1.74 units of gas in order to make that 1 unit of hot water. I could also use electric resistance, another very common solution, and create that electricity with a natural gas power plant. Then the amount of natural gas required is slightly more than that direct combustion, but pretty similar, the two numbers. If I move to a heat pump hot water heater, the amount of electricity goes down dramatically, cutting the natural gas by 2/3. Now, let's move to a world with more renewables in it. That could either be on the grid or on your building. I'm not quite sure what to do with the direct natural gas fired unit, since that was not renewable to begin with. We could move to electric resistance, but the heat pump still uses 1/3 of the electricity of the electric resistance, or 1/3 the amount of renewables would be required. Efficiency is closely tied to that move towards electrification. So as we start to go through this, we're excited to announce today that we'll be using Slido, an interactive platform for questions and answers. You can go to slido.com with your mobile device or opening a new window in a browser. And today's event code is DOE. If you would like to ask our panelists any questions, and again, I kind of challenge you with the big question of why don't you electrify everything today, please submit them anytime throughout the presentation. We'll be answering your questions near the end of the session. You can also select a thumbs up icon for questions you like, which will result in the most popular questions being moved to the top of the queue. We're going to start things out with a few polls so we can learn about you, our audience. Please go over to Slido and respond to these polls. So the first poll we want to ask is, what sector do you work in? And so you can select one of those, and you'll see in real time those answers coming in. We've got a lot of state and local government folks. Higher ed is right now coming in second. And then we've got some industrial and manufacturing. That's great because a lot of this is dependent on the manufacturing sector to decarbonize. And then we also have some higher ed folks. So as you kind of work through this, we have well over 100 people that have already participated in the poll. So if you'd like to join in, please do so now. And when this settles out, we'll move to the next poll. All right, excellent. So the next poll question we have is, when do you plan on electrifying your buildings? And so we can go from you're already there or you have no plans at the moment. And so a lot of you have no plans, so hopefully this webinar will help you think about those plans and some of the possibilities to do that. And again, especially from the half of you that have no plans, you know, what challenges do you face, right? How can the panel today help you think about this and answer some of those questions that you might have? All right, and so then we have one third and final poll for this moment, and that is, what are the challenges your organization faces when it comes to electrification? So again, why don't you just do it? And this is an open text, so you can respond with a text field, right? So yeah, so we've got gas is cheaper, cost, politics, what else is coming through here? Lack of vision, getting the buy-in, getting the dollars, a lot of dollars in different forms coming up here in those answers. Equity, leadership, low acceptance. So panel, I hope you're watching all these things, and during your presentations, you could certainly talk about how you've overcome some of these things and some of the things that you're seeing. Needs to be combined with other upgrades. How do you negotiate with the utility? High electricity rates I've seen several times in different forms. Cost is a priority, right? So that ever important business case of how do you make this happen in thinking about it. I'm seeing lots of different costs, big letters, little letters, more of an explanation that goes with it. So definitely something people are thinking about here. Installation barriers from heat pumps from contractors. Risk aversion, right? And you know, that something about not being the way it has been. Redundancy concerns. Not enough renewables on the grid to make sense with that. So excellent, a lot of good thoughts here related to this. So definitely going to give our panelists something to think about. I think we'll have plenty to talk about here in the next 50 minutes or so. Well, you can continue to put those in for a couple minutes. I'm going to start with our great lineup of presenters, and really ahead of time want to thank our presenters for taking time to share today. First, we're going to have Paul Donohoo-Vallet, is a technology and policy analyst at the U.S. Department of Energy's Office of Energy Efficiency and Renewable Energy. He specializes in electricity sector analysis, renewable energy technology modeling, integration with power systems and markets, and electrification of end uses. And then next we're going to have Christos Chrysiliou, who is the Director of Architecture and Engineering Services for the Facility Services Division of the Los Angeles Unified School District. LAUSD, if you're not familiar, is the second largest school district in the nation, with 13,500, educating a population of approximately 640,000 students. He has over 30 years of experience in architectural planning, development, design, project management, sustainability, and construction. And then we're going to jump back to some colder climates. And Julie Klump is going to be joining us as the Vice President for Design and Building Performance, and is responsible for design and energy efficiency for development projects and the owned portfolio. She assists POAH in the acquisition process with building investigation, energy budgeting, scope development, and cost estimates. For new construction, she oversees design, development, and construction, integrating green and sustainable design. And then we're going to round out our panel with Kent Peterson, who is Chief Engineer and COO of P2S Inc., with over 35 years of experience working in the building and infrastructure industries. Kent is a past ASHRAE Society president and past chair of ASHRAE USGBC IES SSPC 189.1. He is currently a voting member on the ASHRAE Building Decarbonization Task Force and the General Services Administration Green Building Advisory Committee Federal Building Decarbonization Task Group. And with that, I will hand it off to Paul to kick us off.
Thanks, Paul, for that introduction. As mentioned, I'm from the Office of Energy Efficiency and Renewable Energy, and I have two disclaimers. My first disclaimer is that any of the opinions or policy items that I talk about here are strictly my own in my personal capacity, and I'm not representing policy positions of the Department of Energy or the administration. The second disclaimer is that unlike the other panelists, I am an analyst. I am not a practitioner. So when you pose your question of why aren't you electrifying today, I can say, well, it's pretty easy. I go to my model, I turn some knobs, and boom, electrification. It's just that easy. But I know it's not that easy, and that's part of why we're here today. So you can jump to the next slide. What Paul asked me to do in 5 short minutes is to sort of set the stage from an analysis perspective. So I'm just going to quickly offer a few key points for thought for the rest of the panelists and for the discussion. One is why we're here. Well, electrification is critical for decarbonization pathways. We look at any of these fully decarbonization or net zero economy analysis nationwide, any of these big modeling and study efforts, all of them have electrification as a core pillar of the pathway. Here's one example of many that I'm just showing because it's a good example, and this figure highlights that there's 4 key parts to any economy-wide decarbonization. 1, electricity decarbonization, clean up the power sector as low as possible. 2, energy efficiency, take advantage of all those energy efficiency technologies so that's less energy we have to consume. 3, electrification of all end uses that can be electrified. And then 4, for anything that we cannot electrify, we have to use carbon capture or some other carbon capture sequestration end use to take care of that. So electrification of buildings is a core piece of this. It's common in almost all of these net zero pathways and analyses. And the reason why it's useful is, well, we know that there are technologies that exist to do building electrification. The technologies work. Obviously, there are challenges that all be put in that poll, but there are other places where electrification is not possible or not feasible, or the technologies don't exist, and we need to reserve our limited amount of emissions budget for those sectors and end uses that cannot be easily electrified or the emissions can go out of them. Next slide, please. So at the Department of Energy, we have supported a lot of work at the national labs to do electrification analyses. Here is just one of these studies called the Electrification Future Study that was run out of the National Renewable Energy Lab. I'm not going to go into this in detail, but it focused on the power sector side and what the challenges are from the power sector side. And from a modeling perspective and from what needs to be done perspective, the power sector basically would need to grow about double in terms of its infrastructure, the generating units and the transmission. We need to build a lot of new stuff. And while that is challenging, we generally understand it because the way that the power sector is set up, lots of entities and utilities make money by building stuff. So it's relatively easy to understand and relatively easy to see how we could put the policies in place to allow all of this stuff to get built and have the economics line up to achieve that. It's achievable and the infrastructure is possible, it just needs to get built. Go to the next slide, please. The challenges in the building sector, though, as you all are very close to it, is that we're not necessarily building a ton of new stuff. All of the buildings that are going to be around in 2050 in all of these scenarios, the vast majority of them already exist today. So just as a quick analysis on this, this chart shows the Energy Information Administration's historical look at the growth of commercial buildings in blue and the commercial floor space in green over time. And so today we've got about 100 billion square feet commercial floor space. And if we look at the EIA's projections out to 2050, that grows, but only by about a quarter to 125 billion square feet of commercial floor space. So the majority of the buildings, if we're going to have electrified buildings, that stock exists today and it needs to be retrofitted. And as you know, that's a significantly different challenge than just building a lot of new stuff. Next slide, please. So how fast would this need to happen? Again, a lot of these deep decarbonization and clean electricity scenarios can point the way as what would need to happen. And again, here's another study out of Princeton, a recent one, a Net Zero America project it's called, looking at net zero emissions by 2050. And these two slides just show on the left column the sales of different types of commercial heating appliances, space heating appliances on the top, and of water heating appliances on the bottom, and how that translates into total energy demand on the right-hand column. As you can see, and as you know, the long lifetime of building assets and the slow turnover of stock limits how fast changes can really go into the stock. This isn't telling us what's economic, this is just telling us how fast we would have to adopt these types of electric technologies in order to be on the pathway to deep decarbonization by 2050. So because of this limitation of stock turnovers, electric technologies would need to be at about 100% sales well before 2050. And even in the next decade is the time in which we need to be we would need to be ramping up adoption of these technologies. So the early adopters, the leaders, the policymakers, the manufacturers, all got to be in alignment sort of in the next decade to really start if we're going to be on this type of adoption curve. Next slide, please. So finally, just 3 critical areas of thought and path forward to offer from my personal opinion. And I would love to hear the other panelists' take on this and from the rest of the audience. One is finding partners in this. I'm sure you know doing it alone is very challenging, but there are other people out there in the ecosystem who have an interest in electrification and in decarbonization. I saw many of the things come up, say like, well, it's really hard working with utilities. That's not something you can necessarily change, but if you haven't, there are utilities out there that are forward-looking and are thinking about electrification as a business opportunity and as a decarbonization opportunity, and maybe looking for partners to demonstrate how value can go to many different players in this area to achieve many different objectives. 2 is thinking about moving the whole supply chain. Again, I saw many of the poll responses come through that like, well, the installers and the contractors, don't know how to do this type of thing, and I think that's absolutely right. The policies that we've seen to date focus a lot on rebates and tax credits for the purchaser, and while that does make a difference on the economics, it doesn't make a difference if when your boiler dies and you need to replace it immediately, the contractor who comes says, well, I don't know how to install it. I don't have that electric heat pump water heater on the truck, nor do I have an electrician with me right now. So, maybe you have a tax credit for it and that's great, but it's going to take some time before I can get around to it. And that's a major barrier that needs to be addressed beyond just these end use incentives. And finally, thinking about buildings as a system. Electrification can't be thought of just as a drop in replacement. The whole value's got to be seen as how electrification works with efficiency, with net zero ready buildings, all working together to see how the building electrification fits in providing value to building owners and building occupants and achieving any of these objectives. So I will pause there, and I'm excited to hear what our other panelists have to say.
Great, thanks, Paul. And now we'll hear from Christos in Southern California.
Great, thanks, Paul. Thanks for the introduction. Appreciate it very much. And I want to thank the Department of Energy for always having these very interesting and current sessions for us, because even all of us here on the panel, I think we get inspired from each other, and hopefully we can inspire you as well, so you can be able to achieve some of the things that we'll be discussing today, or increase your planning. So being the director of architecture engineering and overseeing sustainability and energy gives me a unique perspective of things, and that's why I'm so interested in electrification myself. And certainly when you manage a portfolio of LA Unified, as Paul was mentioning earlier, we have over 13,500 buildings, and we're carrying over 6,500 acres of land approximately, spanning all the way from Puerto Rancho all the way to San Pedro. So it's a large district with a lot of buildings throughout. And we utilize about 500,000 megawatt of electricity per year. Sorry, 500,000, yeah, megawatt of electricity per year. Can we go to the next slide, please? So a little bit about our sustainability. We have our focus areas that we have been working for the past actual decade or so through a resolution that was passed by our board, and we continue focusing in those areas. But what's important is that what happened about a year and a half ago when our Board of Education passed another resolution. Can we go to the next slide, please? So back in 2019, in December, our board passed a resolution, and I very appreciate their forward thinking, for us transitioning LA Unified to 100% clean, renewable energy. And the whole concept behind this is actually what is saying here. That's going to result in healthier students and more sustainable, equitable communities. And that's something that we should be thinking more than anything else, because at the end of the day, we're here to solve the climate crisis, and these goals will help us get there. So, so we're focusing in electrification by 2040, but also we're looking at renewables, renewable pathways by 2030. And I'm showing some of the electricity usage that we have in terms of dollars and also megawatts, and natural gas, because all those have to transition to electrify our buildings, and we'll have to come up with possible solutions and scenarios. Let's go to the next slide, please. So this is some targets that we've set up, working with the Department of Energy and discussing setting up baselines at 2014 as a baseline with a 2024 target goal for 20% reduction. And then in 2019, the resolutions that passed that we're targeting by 2030, 100% electrification, and 2040 targeting pretty much electrification in all sectors. We're going to be focusing on the 2040 target on this presentation more than anything else, but it's important to note that all these targets that we have do help us plan ahead and think how we're going to be able to electrify our buildings by 2040. And you can see the actual greenhouse gas emissions that we've been having. The EUI, the energy usage index, as we're showing here, being over 35 average for our buildings, and trying to kind of minimize that and bring it down to 20 as a target, or a little bit less than 20. And then our high electricity use that we have, natural gas, and pretty much just being free from gas throughout the entire district. Next slide, please. So how do we move forward? What do we do? And this is where we come into our clean energy plan and thinking through different processes. I think, as Paul previously mentioned also, there's a lot of thinking that comes to place, and certainly you cannot do this alone. You have to work within the different divisions. LA Unified it's a large district. We'll have to look at all of our divisions, understand the needs, issues, identify stakeholders that we have to work specifically, and that's what we did. Both internal and external, look at the deliverables that we have to put together so we can be able to put a plan together, and certainly collaborate with internal and external partnerships, mostly with our utility agencies, so we can understand their planning as well. And certainly through this engagement, we're able to learn, share information, and then we're able to identify pathways that everybody will be comfortable with, so we can be able to reach our goals of 2030 and 2040. Next slide, please. So when we look at pathways, there's different ways that you can look at pathways and different ways you can solve always an issue. And certainly for us, this was becoming a little bit of a challenging. And And focusing on a specific pathway is the effort that comes into place and what's best as also as a business decision for the district as well. Let's go to the next slide, please. So after we talk about it, a lot of different pathways, the one that always makes sense is the same one as we look for zero net energy. Always do the best that you can by slowing your meter through awareness and conservation. It doesn't cost you any money. Focus in energy efficiency by applying all the efficiency measures that you can. There's a lot of efficiency measures that are not costing us. Actually, there's a lot of savings out of it more than anything else. And then introduction of renewable energy to be able to at least achieve the renewable, the 100% clean renewable by a target milestone. Renewable energy today, it's very different than it was 10 years ago. And there's plan and pathways you can get there with very minimal, actually with even some cost avoidance if you follow through the process. And then certainly solving for the 2040, looking at renewables and the transitioning to clean energy, you can achieve your 2040 milestone. And our actually transitioning to clean energy is not starting after the 2030 milestone. It started actually a while back, and we just have to put more emphasis on it. Next slide, please. So here we've kind of going through an analysis to see what is our energy, who are the utility companies, and how do we, how much energy are getting provided per utility, and then what is the plan moving forward, and what is the kind of plan that we have to solve in terms of the transition to clean energy. And what you're seeing here is actually that 106 megawatt of power that we have to solve to be able to transition to 100% renewable. But something that happened along the way is that it was actually working with the LA 100. If you're not familiar with the LA 100, it's a study that was conducted by NREL, the National Renewable Energy Lab. And what was quite interesting about this study is that it's actually has proven and confirmed that you can have an affordable, reliable, and sustainable power system that is running 100% renewable energy. And that is very achievable. So it's you know, there's different pathways, and I urge you to look at that study because there were thousands of simulations that were done to be able to show how that can be done. And certainly some other things I'm going to talk about on the next slide. So let's go to the next slide, please. So when we're looking at this transition and focusing up on how we convert our gas systems to electric, for us is to identify, first of all, what uses gas. And certainly there's a lot of things that we have within facilities, but also equipment that we use to maintain our schools. Let's go to the next slide. So looking at our buildings, we have different types of buildings. Our building portfolio has gymnasiums, classrooms, administrative facilities, 2- or 3-story buildings. We have auditoriums, we have our food services, and certainly all these different types of buildings they use different types of equipment that we have to focus on those specific equipment to be able to transition to electrify our buildings. And certainly, you know, we do that by updating our specifications, and we look at kind of the service life of those equipment, with the idea and understanding that at a certain time we have to transition. And why not transition by looking at you know, what's more efficient and healthier for our students and the environment. So we're looking at ground opportunities. We're looking at modernizations. We modernize our buildings to take advantage of these opportunities because we have time, and we can do it within the time frame. Next slide, please. So we're continuing. If I was to kind of give an overview of our roadmap, and I think it's going to be similar throughout, is that we're continuing through our ongoing efficiency planning, looking at low-hanging fruit by our lighting systems, upgrading those to LEDs, certainly throughout the facilities. We're looking at the building envelope. We're looking at glazing. We're looking at optimizing pretty much the configuration of when we modernize our buildings to see how we can create more efficiency, and looking at our mechanical systems. We're working through pretty much all the different areas of the divisions that we have within LA Unified, engaging, discussing with transportation, looking at health and safety. We're looking at instruction and also food services us, because of the size of the district, we have to, work together. But also, I mean, these are independent divisions that we have to make sure we share information to meet this pathway. So the Energy Task Force that is looking at this, and we're working closely with this, it's putting together a plan, and the plan is to be presented through the task force and then to our Board of Education for approval. So a lot of this planning, it's in discussions, and part of the planning, it is to test new systems, it is to test proposals for solar or new equipment and how we can be able to find more efficient systems that are electric through the industry. So working with the industry, but also we're looking at our design standards and specifications and how we can be able to alter those as we move forward. It's easier for new construction, but modernizing buildings perhaps a little bit more challenging, and that's why we're upgrading our specifications to reflect that. Next slide, please.
All right, so Christos, we need to kind of wrap it up here.
Yeah, and then I'll wrap it up. So there's some of the challenges that we're sharing, and we heard about them: funding, maintenance costs, life cycle costs. Just electrifying in general, some of the underground infrastructure, cost of electricity, scheduling to the infrastructure, and some of the solutions that we're sharing here is to replace some of the equipment that we have, and some of the things that I talked about earlier. We're looking at hybrid solutions, we're looking at induction cooking, we're looking at piloting all these new technologies for mechanical systems and upgrading our specifications. So these are things that right now in the planning, and we're incorporating as we move forward. Next slide, please. And I'm going to close with that again, it's quite important for us to continue electrifying our buildings so we can provide a cleaner, healthier, sustainable, and equitable learning environment for our students. With that, thank you, and Paul, I'll turn it back to you. Thanks.
All right, thanks, Christos. I will now move to the Northeast and Julie.
Hey, everybody. Thanks so much for having me on this panel. It's certainly a great topic, and look forward to the conversation about it. POAH has made a few good strides in electrification towards our goal of decarbonization. We all know that the grid isn't perfect, but we feel like the best we can do is to get our enclosures as robust as possible, switch to electric heating, cooling, domestic hot water where we can. Where we can't, to at least design whatever system is still fossil fuel to be ready to make that electrical jump whenever the technology catches up. So this slide that's on the screen right now is what we do in new construction. Mostly, if not all of our new construction is committed to passive house. And so we have several in design, one under construction, and we feel like passive house plus renewables can easily equal net zero. The density that we build, a lot of times we're going to need offsite electrical. And you can sort of see there's some notes on each of the projects that some are all electric and some require gas domestic hot water. That's one challenge we have in New England and in Illinois, that gas is so much cheaper than electricity, so that's a big hurdle for us. In the building up in the right corner with the yellow sort of opaque glazing, that's the other hurdle that we're facing there. Is we have a design for a solar storage system there, but when we submitted for our building permit, the phone sort of rang off the wall with effectively telling us try again. I think so. We plan to work with the fire department and the building department in Boston. What they've told us is that there's a lot of batteries in service, but they've blocked them all out because they just have real concerns about safety. So next slide. So I just want to walk you through one project that I'm pretty excited about. It's a two-tower, 10-story building with 281 units. It was built in 1973 when code allowed the brick to be supported from the ground up, with very few brick ties holding it back to the structure. When we approached our rehab for this, we kind of expected to do some repointing and maybe reattachment of some brick. And what turned out when we started opening the brick walls and doing some more investigation was that the brick would have to come down. And it's unfortunate in terms of the cost of the project, but it's very fortunate for me and my team because we get to really tackle energy efficiency here. So next slide. So you can see on the far right, the existing brick cladding is sitting over a metal stud wall with some bad insulation. The graphic in the middle shows that we are coming back with a new product that we're pretty excited about. It's called Armor Wall. It's a structural insulated sheathing, and it can be used on high rise. It passes some of the fire tests that some cities are concerned about on this size building. And what it allows us to do is attach that sheathing product to our structure and then attach our cladding to the sheathing that's part of that structural panel, which means that we've avoided all thermal breaks and given ourselves an air and water barrier because that's integral to the structural panel. And then the cladding we've chosen for this one is aluminum. The graphic on the far left just shows that we are adding 6 inches of insulation to the roof. So we're going from probably an R5 wall to an R30 wall, which is pretty exciting, as well as really good windows. So we're excited about this enclosure upgrade and feel like that's the place to start on any project. Next slide. So you might have noticed in the photograph that there were through wall sleeves for air conditioning, which is not good for the enclosure and not necessarily an efficient way to cool the units themselves. So we knew we wanted to add fresh air to build to the units. We knew we wanted cooling without a through wall sleeve. So due to some structural constraints in the building, big I-beams that we couldn't pass through from a ductwork run through the hallway, we ended up using the Minotaur. We installed it in a management office that was a former unit and only heard good things from the staff that used that unit in terms of the fresh air. So basically it's heating, cooling, ventilation in a box. We're building a closet on the exterior, intake, exhaust, going through this as acting as an ERV as well as a cooling system. There is a boiler, fossil fuel boiler and domestic hot water system. That heating system will be supplemental to this. So effectively we have an all electric heating, cooling, and ventilation system. Next slide. And then finally, probably the most exciting piece of this for me is that we're installing a vertical solar PV array. So in combination with the rooftop array and this south wall, this building sits really high up on a hill and has no obstructions to the sun. So we're excited that with the combination of these two arrays, we should offset at least 50% of our electricity. Next slide. So, you know, just to wrap up, I mean, how close are we? What we consider the most important thing is to get the energy efficiency in the building and spend the money there. So when we do a rehab and we have to replace cladding, we're going to get continuous insulation. We're going to get a robust enclosure. We're going to buy the best windows we can. It's not always a triple pane. Sometimes we have hurricane resistant parameters we have to meet, but we do the best we can. It has been a challenge to convince our lenders that doing an enclosure upgrade can't be done on turns. And so doing kitchens and baths sometimes has to be sort of, that priority has to sort of be brought down a little bit in order to concede to making the enclosure. And then without a robust enclosure, I don't think it's fair to do all electric heating. I think sometimes those systems can't keep up. We are trying a new technology that has a heat booster. That's an all electric hydronic electric heating and cooling system that we hope is going to be a real solution for us on our historic buildings where we can't do as much to the enclosure as we'd like. And then of course the renewable system, to the extent you can cover your roof, use offset or offsite, and then we'll let you know how it goes with the wall mounted array. So I appreciate everybody's time and look forward to some questions.
All right, thanks, Julie. And finally, let's move to Kent.
Thank you, Paul. I'm going to be able to provide you a consulting engineer's perspective on at least building electrification and some of the challenges that we've been running into and where we're at right now on this. Good, next slide, please. First of all, just perspective on that first bullet of the size of firm we're coming with. Most of our designs are in the Western United States, kind of taking a different approach than what Julie's doing on the East Coast and the cold climates. And we find different things I'm going to share with you. The vast majority of our current new construction projects are all electric buildings. So when in a firm like ours, that's very important, because when we start seeing vast demand for all electric buildings, whether it happen to be the local codes or the state codes for these things, we might have 20 or 30 buildings in design at any given point in time. And so we need to be able to react quickly and be able to do it right. I can tell you that we also provide a lot of solutions for reducing carbon in existing facilities. So as part of my slides are going to focus more on existing facilities, because my next bullet kind of hits on the point that I'm going to make the generalization that all electric buildings that are new are relatively easy when compared to retrofitting existing large buildings. And they're even easier when we get under 20,000 square feet. So that's a lot of the building stock that's out there. It's when we get into the more complicated institutional type facilities that things get more complex. And like other speakers have said, building efficiency by far is #1 priority order when we're talking about electrifying buildings. Next slide, please. So what are some of the challenges? Definitely, I would say that the engineering community is not well trained in all electric heating options, costs, and obstacles. And whether we're talking about heating or we're talking even about going domestic hot water, there's so many options out there. And how we responded to that as an engineering firm is we created a 20-person building decarbonization task group internally that included representatives from all of our offices in various disciplines to basically set the course of what our firm needed to do for all of our clients to make sure that we're doing the same thing through all our offices and coming up with the right solutions for the right clients and the right types of things. So that's important, because I think we need a lot more education in our industry. Space requirements are going to be vastly different when we look at all electric technologies for many things. When we compare it to being used to using condensing boilers, whether we're talking about a gas water heater or we're talking about a gas boiler, there's a lot more space requirements, and those discussions really need to occur in the conceptual design phase. Next slide, please. We also found that when it comes to modeling challenges on the engineering side, that one of the predominantly used load calculation platforms in our industry grossly overestimates the actual peak heating loads in buildings, sometimes by 200% and greater. And this is backed up by us actually getting trended data over years of analysis on the buildings that we designed and operated, and then running our Energy Plus and ISVE simulations. And what we found is Energy Plus and ISVE more accounted for the sizing we were seeing in the trend data, and our load calculation software that we were using, while not a big deal when you're doing gas boilers because it's not a big expense, it's a huge deal when you're doing all electric solutions where the cost is much greater. So we've basically decided we're not using that platform. That platform is soon to be, I think, to be replaced next year with a different platform by the manufacturer that provides it. Also, on energy modeling software, many people are looking at heat pump technology when there's simultaneous heating and cooling that occur, might be domestic hot water and space heating when they can actually use the chilled water that's coming off of that. And there's currently not any platform out there on an energy modeling side that can actually model heat recovery chillers in a heat follow mode. They model them in a cooling follow mode, and that's not the way you would operate it if you're providing it to provide your primary heating and get the cooling as a secondary effect. Next slide, please. This is talking more about existing facilities, but there's a lot of existing large institutions out there, and I'm sure people on this webinar, where you have existing systems that are providing 180-degree water, whether it was supplied by steam or provided by boilers, and those are all connected to one-row coils. So whether those are heating coils or reheat coils and VAV systems, going to all electric can be much more complicated in those type of facilities. And my advice is don't be afraid to do partial conversions in existing facilities. I'll give you that example on the next slide. So the second bullet here is about reliability data, and that reliability data is not available on a lot of these electric technologies. So we've got to push our industry and the manufacturers to start to get some of this reliability data so we know what kind of redundancy we need to be put in when we're doing compressor technology versus doing gas boiler technology. This slide is an example of a retrofit of a 10-year-old LEED Platinum building that was converted to all electric. We designed the original building that was LEED Platinum, but this is very typical of what we're seeing, at least in the Western United States, when we look at heating load profiles. 1.0 on the bottom being the size capacity that was installed in the building. This one happened to be 22 BTUs per square foot. And what you see over here on the left-hand side on the green bars is what the distribution of the actual load is for the percentage of operating hours of that system. And so you'll see just those two left bars make up over 60% of the operating hours were less than 2.2 BTUs per square foot. That's extremely low. I mean, we're talking about less than 10%. And so you have the ability in these types of systems to put in, if you want to go for existing retrofits and you don't have the, you don't want to put in the cost of a full all electric system. What we're seeing, at least in the Western United States, is we can put in 20% of the peak on an all electric technology, supplement it with a gas boiler technology that's running at 180 for those peak conditions, and still offset 80% of the carbon emissions that are coming from the gas boilers by being able to do that. And that, from a life cycle cost standpoint, is a good solution when you're looking at retrofit solutions. Next slide, please. The last one I wanted to do is at least talk about challenges in refrigerants. And refrigerants are an important aspect to all electric buildings. We're talking primarily about compressor technology with refrigerants. On the first bullet there, I show you the different refrigerants we're currently using today. With what their ambient restrictions are normally around. So if you're below 35 degrees, R134A is not going to be a good solution for you. You're going to have to go to R410A. But these are HFC refrigerants, at least the two on the left. The CO2 is not. And HFC replacements, in many cases, like California, we're starting to see things being phased out. So we're going to have to move into the replacements are A2L, lower flammability category. We were all dealing with no flammability on the HFCs. And so that changes to more stringent requirements in the new ASHRAE Standard 15. So keep those things in mind when we're doing that. Right now, R32, in my opinion, appears to be the strong choice for non-HVAC heat pumps. But the manufacturers ultimately will make which choice they want to go. Last slide. I think that great building envelopes provide the best all-electric buildings, in my opinion. We're talking about new construction. The most we can do, I mean, it changes the whole paradigm shift and cost effectiveness. So what was cost effective when we were looking at gas technologies to do heating and buildings changes when we go to all electric technologies. And so we're finding that things that we couldn't justify, we can justify with the electric technologies to then downsize the electric technologies and get a better overall project and not increasing the construction costs of the overall project. So there's a lot of trade-offs on these things, and that even includes heat recovery technologies that might be used in doing that. We need to seize the opportunity to make the largest operational carbon reductions, I believe, as an industry in our existing building stock. We certainly, as I said, it's an easy thing to start doing all electric new building construction. And we really need to look at what we can do. And we don't have to go all electric in some of these reductions. We can, as I said before, if we went electric for 20% of the load, we found it actually reduced 80% of the carbon emissions from the heating side. Keep these things in mind when you start looking at life cycle costs. And then we also need to have a very good understanding of the heating load distribution profiles, both for new construction and on existing buildings you want to retrofit. Get that trend data before you actually start sizing any of your replacement systems that are going to be out there. And the final thing is ample training is necessary to transform the market in the entire architect, engineering, and construction markets. Thank you.
All right, thanks, Kent. Let's bring back the panel. And we have gotten a huge number of questions here. I'm going to characterize some of those. The first characterization is been a lot of questions around how to move from gas to electric. And that could be one person was talking about their building is currently heated with gas boilers. How do I electrify that? Somebody else is talking about a limitation on heat pumps to 20 tons, especially when you talk about things like rooftops. How do we electrify that? And there were other related questions to that. So maybe Kent, we'll start with you and you can give us some thoughts on how we're going to get this equipment.
I'll build a little bit on what Julie indicated earlier. When it comes to actually electrifying, the first thing we want to do is, even if we're designing buildings today and you're not electrifying them, let's set a criteria on what the requirement should be. If we're going to today use natural gas boilers, for instance, in their condensing systems, we should be using low temperature heating hot water systems, if that happens to be heating hot water for reheat or anything like that, that can easily drop in any of the new technologies that we're going to do. The second thing is that when it comes to what you can do to be cost effective, definitely, as I said earlier in my presentation, we can be cost effective by trying to right size the electric technologies that are going to be there to get, like we do with energy efficiency retrofits, what's going to give me the most bang for my buck in terms of reducing carbon emissions in the building and understanding what needs to happen out there.
Anybody else on the panel want to chime in on the kind of direct replacements and how to electrify the gas boiler?
I'll say a number of the things that I've seen have echoed what Ken is saying, that the hybrid solutions are pretty cost effective at avoiding having to build out for electric just for those really cold heating design days and rely on the gas for those days, but you could meet a significant amount of the rest of the days with an electric system.
There's also an opportunity, Paul, to couple your domestic hot water with your heating hot water. This is more for new construction, but we found a lot of savings by us being able to take our heat recovery chillers and preheat our incoming cold water going to the domestic hot water system, and then downsize those by half for those type of systems. So there's a lot of ways we can play with the way we connect these systems together and use the synergies when we have simultaneous heating and cooling.
Oh, and Julie, you approached some of that with the ventilation air, right? And trying to capture some of that energy leaving the ventilation air to help with the heat pump, correct?
I don't think so in this project. I know we're looking at a new system that's coming out that does have some capability. We're not using it for the domestic hot water capability, but there is a way to install the system, the HEX system or the hybrid VRF system. And the reason we like that system is because it becomes a hydronic system. We really minimize the refrigerant in the building. And it has a booster, which allows us our enclosure to not be as good. And it also has the capability of creating some hot water with the rejected heat.
Yeah, I was thinking on the ventilation air system where you've got the ventilation air leaving and the energy associated with that, and you're putting that energy into the inlet with a heat pump between those two streams.
Yeah, and that's just the way that Minotaur, the Pentacare system, that's the way that system works. I mean, it's basically an ERV, that also provides heating and cooling. But don't ask me how it works.
Okay. No, the magic box, right? I think.
Yeah, the magic box. That's what I call it.
Yeah. So there was another kind of flavor of question here related to kind of the reliability on the electric grid. Somebody mentioned, Texas this past winter and extreme weather events. Isn't electrification putting all the eggs in one basket? That was one kind of line of questioning there. How does the future security and stability of the power grid factor into electrification? Would somebody on the panel like to address that and you're thinking about that?
Yeah, I can take a stab at that from the system perspective, and I see some of the commenters on that one already addressed it, but that the gas system and the electric system are already intertwined and they're inextractable. As many people point out in the Texas event, you need electricity to start your gas furnace or your boiler in many cases. And from the system perspective, there are electric pumps that run the gas pipeline system. And if those aren't receiving electricity, you can't pump the gas either. So these systems are already intertwined very well. Similar, people talk about electrification and gas, or like gasoline for cars. You need electricity to run the pumps to move the gas out of the underground tanks into your car. So keeping the electric system secure and reliable is always critical. And I don't think that there's a significant change in that as we move towards electrification.
Yeah, and I can touch on that, Paul, in terms of even my experience with the LA 100 study that was conducted the last 4 or 5 years for the Department of Water and Power here at Los Angeles. Is what we've learned is that when we started, we were very actually concerned about this and this question specifically. And then what we're able to find out is that you can reach 100% renewable with the sources that we have, and you can have the reliability that you need. And certainly, if there's any concerns about that, you can always have a backup solution, a backup scenario for that. But in terms of our buildings and our systems, as Paul was just mentioning earlier right now, I think it's unfair to say that if you don't have gas, your buildings will shut down. They will shut down if you don't have electricity. I mean, it goes both ways, right? If you don't have electricity, it's going to shut down. If you don't have gas, it's still going to shut down, right? So it's not going to function just with the gas only. So bottom line is we have to find solutions. There are hybrid solutions, and we can have again alternate solutions like battery backup storage or other solutions to be able to maintain electricity in our buildings so we can continue their operations.
All right, thanks, Christos. So this question is probably the two Pauls on the panel aren't directly involved with this, but the other three of you deal with cost every day, right? As owners or as on the engineering consulting side. We've got several questions around cost. How do you address the cost discussion? And then there's kind of a follow-up onto this. Are there things that we can do to reduce the cost of electrification? And maybe some ideas around that. Some of that may be futuristic or things that you can implement today.
And I'll just throw out there that it's interesting that in New England or Massachusetts specifically, you know, the incentives for us doing passive house allow us to do it, because what those incentives are doing is they're covering the premium and construction costs until the market is sort of aligned. We have some cost parity. When we move to Illinois, where we're starting to do some passive house buildings, there's a lot of training that has to happen, because immediately people hear passive house and there's like this, you know, mystical escalation that pops in just because people don't understand that it's that, you know, we're doing the same thing. And then similarly, when we go to DC and do a building there. So I think it's going to take, what we try to do is a lot of training with subs and GCs and estimators and architects and engineers in order to bring them along on this. And I think the training helped us go from a 8% premium down to 2% on our project in Boston. So I think to the extent utilities can incentivize it, or there are special grant programs, once we can get the market moving in the right direction, the whole notion of building a nice robust enclosure that allows for electric systems is gonna happen.
Anybody else want to comment on the solution to cost? Absolutely. I would agree with Julie on this, because when we talk about costs, I mean, we could talk about first costs, we can talk about life cycle costs, so we should probably talk about both. But I think Julie was talking primarily about first costs and trying to get those first costs to be more equal to each other. But as we said in some of our presentations, it makes a huge difference on what we do on the building envelope and downsizing and looking at the overall solution than just taking a given load and saying, now I'm going to compare this to my condensing gas boiler and compare what my electric heating option is. If I can downsize that by doing other things, and even as I said before, being able to take some of that and connect my domestic hot water requirements, if ever going all electric, with my space heating requirements, now I can actually reduce the first cost substantially. We figured out ways to reduce the first cost, but we've also figured out on many of these buildings that we can actually get the life cycle cost when looking over the 20-year operation, that it's going to be cheaper with the electric solutions if we're taking building efficiency into account.
Pathway in place, we have to start thinking about in terms of the life expectancy of our existing systems, when they're coming, they have their service life, and then start transitioning and do the transition to the new systems. After you test them, you make sure that, again, they're fine. And you're going to find out they're not more costly than what you're paying to replace a system with a gas system.
All right, thanks. Now that we've got my unmute working here. That is going to be all the time we have today. Thank you very much. A lot of great discussion related to this. As mentioned, this is part of the 2021 summer series. We have a great lineup of presentations through August. Visit the Better Building Solutions Center to register. And we hope that you will join us on the 15th for our next webinar titled Becoming ESPC Ready. Join this webinar to better understand the basics of energy savings performance contracting and how it can help you. And then if you want to watch any of the recordings from any of the series, you can go to the on-demand webinars library where all the previous recorded presentations are archived. Thank you so much for joining, and we look forward to seeing you on a future webinar.
Thank you, Paul.